Assalamualaikum warahmatullahi wabarakatuh. We were from Group 2 of Continued Organic Chemistry Practicum with Laboratory Assistant Ahmad Fikri Darulhawas and Advisor Lecturer Ahmad Ningsih, MSc, and Ahmad Hanafi, MSc. On this occasion, we will explain about isolation and identification of the alkaloid from Pulai leaves.
Introduction. The main ingredients of our research is Pulai plant. Pulai is the botanical name of Alstonius coloris. This plant is included in the type of hard plants that live on the islands of Java and Sumatra. The quality of the wood is not too hard and less preferred for building materials because the wood is easy to curve if damp, but widely used to make household appliances from wood, carvings, and sculptures. The benefits of Pulai plants are strengthening the stomach, can treat such illnesses as fever, diabetes, biliary, cough, asthma, dysentery, hypertension, anemia, epilepsy, and also serve as anti-inflammatory, anti-cancer, and antioxidant. A secondary metabolic content of Pulai plants: on the bark, there is a content of saponins, flavonoids, and polyphenol. On the leaves, contain several compounds: acubin or aradoid, coumarin, phlebatannin, phenolic alkaloids, flavonoids, saponins, tannins, and steroids. In leaf extract with sulfan ethyl acetate, found the presence of alkaloids, terpenoids, and steroids. On bark extract are only found terpenoids, and at the root, found the presence of alkaloids, terpenoids, steroids, and saponins. On leaf extract with methanol solvent indicate the presence of alkaloids, steroids, and saponins. On the bark and root, found the presence of alkaloid, terpenoids, steroids, and saponins. And one of the secondary metabolic contents of Pulai plants we are insulating is alkaloid. Alkaloids are alkaline compounds containing one or more nitrogen atoms that are often present in heterocyclic rings. In plants, alkaloids have a role to help defense against herbivorous attacks because alkaloids have a very better taste. Alkaloid compounds are generally insoluble in water but soluble in ether or chloroforms and other nonpolar solvents. Alkaloids are usually obtained by extracting plant material using solvents or reagent of chloroforms, acetones, methylene chlorides, and ammonia. Extraction of alkaloid compounds derived from plants can be done using alcohol-type solvents. They are weak acidic because alkaloids are alkaline, and precipitated using concentrated ammonia. Furthermore, liquid extraction is carried out.
Okay, I explain it related to the research background. Based on the explanation, it is necessary to isolate plant leaves, so it get the identification result of organic compound in the form of alkaloid from plant leaves, or Alstonia scalaris LRBR, which is useful for providing information related to its existence, the content of alkaloid compound in plant. The purpose of this research was to determine the result of the extraction of alkaloid compound in plant leaves, and also to determine the characterization of alkaloid compound in leaves Pulai. In this research, I am to extract alkaloid from Pulai plant and will be done by maceration method by ethanol solvent. And then the identification use spectrophotometer UV-Vis, FTIR, HNMR, and then GZMS.
Research methodology. Step for research methodology is sample preparation, Pulai leaf extraction, isolation of alkaloid compounds, and identification of alkaloid compounds. The first is sample preparation. The step is Pulai leaf was until clean and cut into small pieces, dried in the sun indirectly, and then blend, and then sieved with a 8T mesh sieve. Second is Pulai leaf extraction. The step is Pulai leaf powder, weight 100 grams and divided into two parts, and then maceration extracted with ethanol for 24 hours, and then second with a cycle for 3 hours and filtered. It is macerated again using ethanol as a solvent, and then repeat until a colorless filtrate is obtained.
Isolation of Pulai leaves. Dissolve Pulai leaf extract with a 2% solution of sulfuric acid. Add the diethylator. The diethylator fraction was removed. The water phase is taken. Maceration using 25% ammonium glucide to pH 9 until 10. Extract with 15 milliliter of chloroform until clear. Extract using a rotary evaporator. Flow with nitrogen gas. The yield is calculated. Monitoring using thin layer chromatography. Mark at the bottom outline of the plate. Oven it at 100 Celsius for 30 minutes to activate silica. The concentrated extract of Pulai leaf alkaloid was dissolved using solvent. More or less thin spots on the plate with a distance of 1 cm from the bottom edge of the plate using a capillary tap. Let the plate dry. Dilute the sample spot with each mobile phase, ethyl acetate, methanol, water with a ratio of 6:4:2. Insert the plate into the grid chamber. Close the grid chamber until the mobile phase reach a distance of 0.5 cm from the top edge of the plate. Let the plate dry. Stains were observed on silica under UV light with a wavelength of 366 nanometer. Marked stains are visible with drag and drop region. Reobserved under UV light with a wavelength of 366 nanometer. Marked stains with a pencil.
Now I will explain about the identification of alkaloid from Pulai leaves. Identification here functions to obtain information on the types of the alkaloid found in Pulai leaves that we isolate. The first identification with spectrophotometer UV-Vis. The UV-Vis spectrophotometer is an analytical method for measuring the concentration of the analyzed compound based on its ability to absorb or absorb light beams at UV-Vis wavelength, namely in the absorption area of 350 until 800 nanometers. The steps is isolate concentrate extract, First, dissolve 0.1 milligram of isolation with 2 milliliter of methanol. After that, pipette as much as 2 milliliter. After that, put in the cuvette, analyze with a UV spectrophotometer at a wavelength of 200 until 800 nanometer, and finally observe and record the wavelength formed. And the next identification with spectrophotometer FTIR. FTIR, or Fourier transform infrared, is a type of infrared spectrophotometer which can provide information about the chemical composition of the sample at the molecular level, or provide information about the functional group of the analyzed compounds. The step is isolate concentrate extract. First, taken 1 until 2 milligram of sample. After that, the gas with water-free potassium bromide. After that, compress until transparent pellet are formed. Next, put the pellet in the sample holder, and finally made the spectrum at a wavelength of 4,000 until 500 centimeter minus 1. And next, identification with GCMS, or gas chromatography and mass spectrophotometer. GCMS is a combination of gas chromatography and mass spectrometry, which is useful for separating a mixture of organic compounds into its component and predicting the chemical structure of each of these components. The separation of compounds mixtures by gas chromatography is based on the partition of the component between the mobile phase in the form of a gas and the stationary phase in the form of a non-volatile solid or liquid which is attached to an inert support. The step is isolate concentrate extract. First, the result of the lips extract were added with 5% acetyl acid to pH 3 until 4, and then extract by dichloromethane, and then the separate water phases have add 10% natrium carbonate to pH 10, and then extract with DCM 3 times, and then the organic phase in extract separately, and then analysis of the organic phase containing alkaloid by GCMS. And the last identification with HNMR, or hydrogen nucleomagnetic resonance. The function of HNMR spectroscopy can identify the structure of compounds or molecular building formulas of organic compounds by measuring the magnetic moment of their hydrogen atoms. The step is isolate concentrate extract. The first dissolve in solvent deuteriol form, and then insert into the tube on the HNMR device, and then measure the spectrum in the chemical shift range of 0 until 10 ppm.
And now for the result and discussion. First, preparation. First, we need to wash Pulai leaves to be clean from impurities and then cut Pulai leaves into small pieces to widen the surface so it can speed up the process of drying and grinding. And then dry at room temperature without direct exposure to the sun for 14 days. This treatment for reduce the water content of the Pulai leaves so that the development process of microorganism and enzyme activities in Pulai leaves has stopped. For drying process, which is carried out by airing it in open air, is expected not to damage the secondary metabolites found in the Pulai leaves. And then crush the Pulai leaves in a blender to form a small and fine powder and filtered using a sieve measuring 80 mesh to maximize the surface area of the sample to be larger so that the contact with the solvent in the extraction process is getting bigger. Next, extraction. In this practicum, using the maceration extraction method, extraction is carried out at room temperature so as not to damage the structure of the compound to be extracted. The first step was weighing 100 grams of Pulai leaves powder and then extracting it with ethanol for 24 hours. Immersion using ethanol 95% with a ratio of 1:10. 95% ethanol solvent is caused by alkaloid compounds derived from plants that are alkaloids so that they can use alcohol which is weakly acidic to dissolve it. The shaker was down for 3 hours to maximize the dissolution of the alkaloid compounds, then filtered and macerated again to maximize the uptake of alkaloid compounds. The filtrate is carried by a rotary evaporator, and the extraction result are the yield was 22.57%. Next, isolation. The concentrated extract of Pulai leaves weighs as much as 20 grams and dissolved in 2% sulfuric acid is to attract alkaloid compounds and the formation of amine salts or alkaloid salts, and also to increase the solubility of alkaloid compounds in water. The mixture of concentrated Pulai leaf extract with sulfuric acid was filtered using filter paper to separate the insoluble Pulai leaf extract. The result of acidification using sulfuric acid were partitioned in a separating funnel by adding 15 milliliters of the ethyl ethers, repeated 5 times to remove the fat and wax contained in the acid solution. The partition results will form 2 fractions or layers, namely acid fractions and the ethyl ether fractions. The 2 fractions obtained were separated, then the acid fraction was stripped by adding 25% ammonium hydroxide until the pH range a range of 9 until 10 and form a precipitate to free alkaloid compounds from the salt and form a free alkaloid base. Free alkaloid was then extracted with 15 milliliters chloroform. The addition of chloroform is used to extract and withdraw alkaloid which has been free from its salt because free alkaloid dissolve easily organic solvent, while alkaloid salts cannot dissolve in organic solvents. The result of the extraction with chloroform will form 2 fractions, namely water fraction and chloroform fractions. The bottom layer or chloroform fraction is taken and separated by the precipitate in the filtrate using a vacuum rotary evaporator. The resulting concentrated extract is evaporated by flowing N2 gas, and we get 0.37% yields.
Thin layer chromatography TLC. Thin layer chromatography aims to find the best element from several elements that are good for separating alkaloid compounds. Of the 5 types of element use ethyl acetate, methanol, water, 642, salt to separation. The result producing 6 spots with an RF value 0.08 until 0.76 with the color that appeared on the wavelength observation. 366 nanometer is orange, blues purple, and brown. Identification with spectrophotometer UV-Vis. The alkaloid compounds isolated in dichloromethane give a maximum absorption peak of wavelength max 230 nanometer with a transition of P to P star. This absorption peak indicates the presence of an alkaloid compound indole because this compound is located at a maximum wavelength of 228 until 230 nanometer.
Identification of alkaloid compound with FTIR spectrophotometer. It's from the research that has been conducted by Mufaddal 2015. From the spectra form, it can be identified that the Pulai leaf isolate show the functional group of hydroxide at wave number 3432.979 and CH stretch absorption is at wave 2978.029. Absorption of alkena at wave number 2137.562. Absorption of amina bending at wave number 1645.64. Alcohol absorption at wave number 1047.448. Aromatic absorption at wave number 879.79. Identification with GCMS. In here we get three spectrum from the Julianto 2018. The first spectrum measurement using GCMS after the leaf sample were extract with methanol, 2 times 24 hours, and extract with TCM. In here we got no alkaloid compound were found, with data on the retention time for 19 minutes with 5 peak. It belong to organic compound, beside alkaloid, and other is fatty acid. The second spectrum is the result of the extract per added 5% acetic acid and extract with TCM as acid fraction. This spectrum shows the presence of alkaloid compound in the acid fraction of a Pulai plant with a temperature program of 40 degrees Celsius and 260 degrees Celsius. The retention time was 19 minutes. There were 10 peaks that appeared on the chromatogram. There was one alkaloid compound at the retention time of 16.364. Alkaloid compound of the coronite type with an area percentage 6.79. And the last spectra of GCMS is done 3 times in extraction, and the organic extraction is done separately. There were 3 alkaloid compounds identified that at the temperature variation of 40 degrees Celsius until 260 degrees Celsius, namely ibogamin, coronitidine, and lombin alkaloid compound, which appeared at the retention time of 15.965, 16.335, and 18.017. Identification with HNMR. The spectrum is from Saputri 2011 that give sigma hydrogen 7.71 ppm and sigma hydrogen 7.13 ppm give two aromatic proton in the ortho position, sigma hydrogen 7.71 ppm and sigma hydrogen 7.54 ppm give two aromatic proton of the meta position, sigma hydrogen 7.13 ppm and sigma hydrogen 7.54 ppm give two aromatic proton in ortho position, sigma hydrogen 7.13 ppm and sigma hydrogen 6.77 ppm give two aromatic proton location in the meta position. The methane group that is conjugate at sigma hydrogen 5.82 ppm and sigma hydrogen 7.44 ppm presence of an indole alkaloid derived from the asbidodacin sarpin 3 singlet signal on the sigma hydrogen 3.61, 3.97 and 1.90 ppm. Based on the measurement result of the alkaloid compound is the isolation result of abethane are the type of asbidodacin sarpin.
Finally, we come to the conclusion of this research. Extraction of alkaloid compound from the leaves of the Pulai or Astonia scolaris LR bridge using the method of maceration of ethanol solvent 95% produced a curd extract with a yield of 22.157%. Then isolate alkaloid compound in the extract leaves Pulai produce a pure extract of alkaloid compound with a yield of 0.37%. The best eluent that can separate alkaloid compound from the extract of Pulai leaves is ethyl acetate with methanol and then with water. Eluent by comparison 6 appeals 4 appeals 2 with RF value 0.08 until 0.76. Based on UV-Vis, FTIR, TCMS, and HNMR spectroscopy are known, alkaloid compounds contained in Pulai leaves are alkaloid indole, that is asbidodacin sarpin.
That is all presentation from us. We are so sorry if there are error or apologies. Thank you for your occasion. And wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi